Hi everyone and welcome back to the third part of our server development tutorial. Now that we got our user created, the next thing I want to do is to be able to log in. And in order to do that, I would like to introduce you to Json Web Tokens. So what are they and why are they so important to us? If we'll go to JWT.io, we get to the official Json Web Tokens website. And we can see right here, they're an open industry standard method for representing claims securely between two parties. And as we can see here, JWTs are credentials which can grant access to resources. So what's going on? What is this thing and how can we use it? Well, all it is a way for us to encode and decode our data. For example, user data like name and so on. And when we encode this, we will get this string right here. And as you can see, it is color coded to much different parts of the string separated by dots. And we can see it has three parts: the header, which contains the algorithm and the type, the payload, which is the actual data, and the verify signature, which will contain all sorts of data we can use to make sure our signature is valid. And this last part is actually the most important one, because what it achieves is that because of the way JWT works, our payload and actually everything else is hashed in such a way that if we change even a single bit of our data, our signature will no longer be valid. This is why it is so powerful. Once a user logs in, we can generate such an encoded string, which the user can then use in order to get his user data without us needing to validate his credentials every time. Instead, what we can do is simply validate the signature. And if it is valid, meaning it is not tampered with, then this user is exactly who he says he is, and we can grant him access according to the token. Another important feature of those tokens is that you can time limit them. So for example, if you want a user to be logged in for just a day, you can do it. If you want the token to last forever, you can also do it. So this is what we'll be using in order to keep track of our credentials. This is a well-known open industry standard and it is accepted and used in a wide variety of web applications. So let's see how we can use this library in order to quickly verify our user without requiring any login or credentials besides the JWT. So the first thing I'll do is to import it. I'll say const JWT will be require Json Web Token. Save it and let's install it. npm install save Json Web Token. Let's see how we can use this. I'm actually going to create a function here, async function login, and it will receive three parameters: username, password, and remember, to indicate whether the user checked the remember checkbox, and we should generate the token for 30 days instead of 1 day or whatever time duration you like. The reason I'm creating this login as a separate function and not right here in the login post is because we will be calling this login function not only from this post. So this will make our lives a little bit easier. The first thing I'll do is to handle my token expiration time. I'll say var expires will be equal to 1 day, and if our user checked the remember checkbox, so if it is 1, we'll say expires will be 30 days. The next thing we want to do before we can see how to create our token will be to find our user. So I'll say const user be await, because we are inside an async function right here, meaning it will not wait on anything unless we will call this await. So here I'll simply say user.find1 and we'll pass user. We can say .lean. This applies some Mongo magic that skips the hydration of the result documents and makes queries faster and more memory efficient. Note that if we did not have this await here, because again the function is async, the function will go on to the next lines before waiting for this find1 to return a result and storing it in this constant. So it is required. Now that we got our user, we can see if not user, or user is null, or user is undefined. We can return 0, which will indicate user not found. The next thing we need to do is to validate the password. In order to do that, I'll create a new hash, and then we simply update the hash with the user we found .presalt plus our password that we will pass to the function plus user.postsalt. And if we do this, the two hashes should now match. So all we need to do is to check if hash.digest_hix is equal to user.password. And this will work. There's not much wrong with it. except that we shouldn't really compare passwords like this in our Node application. The reason for it is that it makes it vulnerable for something known as timing attacks. You can read all about it if you like, and the solution for it is to use something known as safe compare. This is a simple library. You can replace all of your compares with the safe compare, and all it does is to make sure every password comparison takes the exact same time, so you cannot get any information by the time the server takes to process the password. However, I'm going to take this opportunity to add another layer of security and use something known as bcrypt. Bcrypt is a very well-known, widely accepted encryption library used in servers, and I'm actually going to add it on top of our SHA-3. I'll just import it real quick. Acquire bcrypt.js, and let's install it. And this now gives us the ability to encrypt anything we like, exactly like SHA-3. So what I'm going to do is say that my password right here is not only equals to this hash.digest.hex, I'm also going to add a bcrypt layer to it. So I'll say bcrypt.hashsank, and here we put the value that we want to hash. So our SHA-3 hash right here, and the number of iteration of bcrypt we want to run on this value. I'll say 10. Please note that the more iteration you put here, the more processing power your server will need in order to create every password, and the longer your server will take to perform this. So please don't overdo it with the iterations right here. Make it a reasonable number that corresponds with your server capabilities. Now if we do this, we will actually need to re-register our user again because our password only uses SHA-3. But now instead of just comparing, we can use bcrypt compare. So I'll say await bcrypt compare. Here we simply put the two values separated by commas, and we finally get to the reason we did this. This bcrypt compare replaces the safe compare. I think this will be just better. Instead of using the safe compare library, we can just throw in this bcrypt, which will also add another hashing layer on top of our SHA-3. So finally, if the passwords match, we can sign our JWT. So I'll say token will be jwt.sign, and right here we can pass the object with all the data that we want to sign in our payload. So I'll pass in the user ID, which will be user.id of our user right here, and I'll also sign its username. Note that we could sign all the important data here that we want to get without fetching the user. For example, if it is a premium user, or if it has any kind of special access rights like an admin user, all can be signed right here in this payload. The second parameter should be a secret, which will simply be a string. So I'll just pass secret string, and let's create such a variable. So I'll say const secret string will be equal to just some random long string. You can just type anything you want here. Just note that if this string is ever exposed, anyone can tamper with your tokens. So this is the most important thing. Next, we can specify the expires in like so, and I'll simply say expires, this variable right here, and that's it. I'll simply return this token, and otherwise I'll return one, which will say incorrect password. Now our function is ready to be used. Our login request will take a few parameters: username, rec.body.username, password, and remember will simply be 0 or 1. Now we can simply say login response will be await login with username, password, and remember. And now this login response object will contain the return of the login function. So we can simply handle it and say if login response is 0, then as we said, this is the user not found case. So I'll write head to set the status code to 403 unauthorized, and I'll simply end. And here I can actually write a final data chunk to our response. So I'll just say username not found. Otherwise, if login response is 1, then as we said, this will be an incorrect password. So I'll say write head 403 as well, and here I'll end incorrect password. And lastly, if the login response isn't 0 or 1, then it means we got our tokens. So I'll write head of 200, and I simply want to return this token to our user. So I'll simply say res.end login response, because as we said, if the login response is not 0 nor 1, then it means we are returning the token itself, so the login response is our token. This is really it. If I save it now, delete my user, and send my request again to register a new one, refresh right here, this new user's password is now a bcrypt password, and we can now try to log in. So I'm going to change this, or actually create a whole new request. post. Here I'll just say login, go to body, change the method to form URL encoded. So as we see, our password was 1234 and our username is test. So I'll enter username test password of 1234 and I'll say remember to 0. If I'll now send it, bcrypt.compare is not a function. Let's see what's going on. I misspelled it. Save it. Try it again. We get incorrect password. As we will see, most problems are mostly syntax. When we registered our user, we passed the key pass right here, but we actually accessed password. So I'm going to change this, delete our user again, we register it, and now we should have no problems. If I'll send it again, we can see we get this JSON Web Token. In our client, we're going to save this token and we can later use it in order to validate our user. So let's see how we can do this. I'm going to create another route here, but this is going to be a get. I'll call it valid token, and indeed this function is going to validate our token, just so we can see how we can do this. And this will also be useful to maybe see if the user's login session is still valid or not. So we're going to pass an async function request, and I'm going to say token will be rec.query.token, and we can begin this by simply checking if token.length is smaller, and we'll say this token will be at least 100 characters. If not, we're not even going to try to waste time and verify it. So if this is the case, I'll simply write head 403 and end. Then I'll return, and in any other case, I'll give write head of 200, and the response will say whether the token is valid or not. So I'm going to create a var user to try to get the user encoded in our token, and we're going to try user equals to jwt.verify token and our secret string. We're going to catch if there is any error. If there is an error right here, that means our verification failed. So I'm going to end 0, which will indicate token invalid, and I can return right here. And if this catch did not happen, we can simply end 1, which will indicate a valid token. And if I'll print it right here so we can see what this token contains, so I'll print user, save it, and now let's try to send this request. So I'll say valid token. This will be a get, and here we'll simply put our token. So I'm going to copy it, paste it right here, send, and we can see we get 1 for a valid token. And if we print it out, we get our user ID, which matches the object ID right here of our user in our database, the username, and those two parameters, which actually contains our expiration data. So this is it. It's that easy to now grant this user access to every resource we want related to its username, because we know that this user has a valid login session until this token expires. The last thing I want to try to do is to tamper with our token to show you the JWT mechanism in action. So as we can see, our payload is the purple right here, and let's say I want to change it. For example, give my user admin rights. So all I'm going to do is to go to the second dot right here and simply change one character. Instead of an N, I'll say Z. Now if I'll try to send it again, as we can see, our entire token is invalid, even though we simply changed a single character. The truth of the matter is, we will have to generate a completely new token, which will change also this verify part of the JWT, and we can only do this using our secret. So that will be all for this one. Hope you learned how you can use this powerful tool in order to handle user sessions quickly and more easily. In the next part, we will explore WebSockets and unlock more of the power of our server. As usual, if you have any questions or suggestions, feel free to drop them in the comments down below. Hope you're looking forward to it, and see you in the next one.